been running on the spacecraft, and this is the longest that we've been out of contact since we've entered encounter rehearsal. This may be a rehearsal, but New Horizons has been firing its thrusters and spinning in space, identical maneuvers to those planned for 2015. On encounter day, the spacecraft will be too busy taking data to send back images. That's why its first simple, "I'm alive" message will be so important. So we'll time it in the next minute. DSS 43 should lock up on the signal. We're good. We're nominal, spacecraft's nominal, and it looks like all the observations that we planned between last track and this track happened. So this gives us good confidence that at least the spacecraft has been performing all of those twists and turns that we've been anticipating it to over the last 7 days. I like to say that at the flyby, I don't want to be learning anything about the ground system or the spacecraft of the team. I want to be learning only about the Pluto system. No spacecraft has ever been to Pluto, nor will ever go back in our lifetime. Pluto is every child's favorite planet. You ask anyone under the age of 6, they're going to say Pluto. We don't exactly know what Pluto looks like, but it looks very exciting from the images we have from the Hubble Space Telescope so far. We really can't wait to get there and see what it actually looks like. So if anybody says that Pluto is boring or not important, no way. Before New Horizons arrives at Pluto, most everything we think we know about the planet and its moons is up for grabs. Virtually every place we've sent a spacecraft on a first reconnaissance mission like this, that we find out that our Earth-based notions were flat wrong. So I'll tell you what we expect, but before anything, what we expect is to be surprised. From the 1990s through today, Stern has been consistent in avoiding speculation. You get the same answer everybody's gotten from me for almost 20 years. I don't make predictions, except for one. My best guess is we're going to find something wonderful. But in the final months leading up to the July 2015 encounter, it's hard for most humans not to imagine what we'll see. Many planetary scientists, like Paul Schenck, base their expectations on what we saw when Voyager 2 reached Neptune, and specifically as it flew by its moon, Triton. Voyager was a 10-year-long exploration of the outer solar system, and every time they got to a planet, it was basically the first time anybody had really seen those bodies. So when they got to Jupiter, they were greeted with enormous surprises. The erupting volcanoes on Io were just completely unexpected. And so when they got to Uranus, there were more surprises. The exotic trains of Miranda and Ariel, for example, were not expected. So by the time they got to Neptune, they were kind of accustomed to the idea that they were going to be surprised. And sure enough, Triton completely blew them away. Bonnie Barati was at NASA's Jet Propulsion Lab as the first images of Triton, a moon of nearly 1,700 miles diameter, came down. Triton was almost a twin of Pluto. It's about the same size, about the same brightness. Originally, Triton was probably a Kuiper Belt object just like Pluto, floating around in space, but then it got too close to Neptune and it got captured by Neptune's gravitational field. Recently, Paul Schenck enhanced the original Voyager data to create this detailed flyover of Triton. It has odd patches and odd blob-like features, kind of like amoebas crawling around on the surface. Triton has very few impact craters. Its surface is extremely young geologically, and it actually has geysers spurting material off into space. Here is a body that is hundreds of degrees below zero. So cold, it's forlorn, it's barren. We just didn't expect to see this activity. On Triton, it was quite a surprise. If you just assumed that Pluto was going to look exactly like Triton, which is the most similar object we know about, then you might expect to find a very interesting body. But Triton is not the only dynamic ice world in the outer solar system. 16 years later, the Cassini spacecraft sent back images of Saturn's moon, Enceladus, about 300 miles across. This is a tiny little moon, and Enceladus is actually a winter wonderland. It's very bright. It reflects almost all the radiation that falls on it. It has these huge ice volcanoes spewing out from its south pole, and Enceladus is continuously giving off puffs of water vapor. And so if you start to see puffs of water vapor coming off Pluto as New Horizons gets closer, that would be exceedingly interesting. But what forces can power volcanoes in the deep freeze of the outer solar system? Triton and Pluto are both balls of ice with presumably rock in the center, and so one of the sources of energy is radioactive decay inside the rock, which gives off heat just like the Earth is heated. If you just let Pluto sit there and pump the heat out of the rocks, you generate enough energy to melt a couple of 100 kilometers worth of ice. It's still possible to have an ocean beneath the relatively thick ice shelf. The ice shelf might be 100 miles thick or so. Over billions of years, the ice shell gets thicker and thicker and thicker as Pluto cools. And as it does so, it squeezes the water underneath. And if you squeeze the water too much, then it may well actually create fractures and the water could jet out to the surface. When you're going out to the edge of the solar system, you kind of have to expect some surprises, and we're going to see them at Pluto as well. Just as Triton and Enceladus were mere dots before spacecraft reached them, until now, Pluto has been an astronomer's planet. That's about the change. We are going to start off as astronomers, and we'll be using astronomical tools to try and sharpen up our images and pull every last little bit of detail out of these fuzzy blobs. We gradually turn from astronomers into geologists as we get closer and it becomes a real world. Jeff Moore was in the room at JPL as those Triton images came down, but he also enjoys field work and thinks we'll recognize some similar planetary processes at work on Pluto as back on Earth, so I'm a geologist. And although we don't expect to see oceans on Pluto, there are common processes which operate on this planet, which are likely to operate also on Pluto and its moons. While the scales are very different, erosion shapes landforms here on Earth and all across the solar system. There are these little finger-like projections that are formed by the process of erosion where wind and water have sculpted this landscape by taking advantage of small differences in the strength of the original rock, creating large, huge, fantastic landscapes, such as on Jupiter's moon, Callisto, and we can anticipate that we may perhaps also see landscapes like this on Pluto and its moons. Pluto's 248-year orbit is more eccentric than our solar system's terrestrial and gas giant planets, greatly varying its distance to the Sun. But it's typical of many other objects in the Kuiper Belt, and newly discovered planets surround other stars. That, plus its highly angled polar tilt, combine to produce strong seasonal effects. In fact, the seasons of Pluto are amongst the most extreme of any seasons on any world that we know of orbiting the Sun, and those extremes may be one reason why its surface is also extremely contrasty. Pluto is perhaps the most intensely bright and dark place that we've seen in the solar system. This dark surface collects more heat, it warms up like asphalt does on a sunny day here on the Earth. And if their Werg frost had settled on this dark surface, they're being heated up and driven off, and the transportation of this material could also be creating wind, so you might see small dunes oriented along the periphery of the dark surface showing this process in action. For planetary scientists, color can be a clue to the composition of surfaces that can't be sampled directly. On the Earth, these kinds of colors from red to dark gray are generated entirely by the presence or absence of rust. On Pluto, we see also these same ranges of colors from gray to bright white to yellow to red to black, but there it must be due to a completely different process. At NASA's Ames Research Center near San Francisco, longtime Pluto researcher Dale Cruikshank and postdoc Chris Medeiros conduct experiments to see what processes might create the colors we see on Pluto, starting with gases like methane and nitrogen and the extreme low temperatures we know are found there. In our cold chamber, we can produce a thin film of ice and then after that expose them to a beam of electrons, which are charged particles, comparable to what comes into Pluto's surface from space. We find that when we shine ultraviolet light or electrons on simple molecules, before too long, the simple molecules are broken apart, and by natural processes, they reassemble into more complex chemicals. So far, the colors we make in the lab from radiating these ices is fairly close to what we see on Pluto. There are tones of yellow, light brown, up through fairly dark red. And if we carry the processing by ultraviolet light to an extreme degree, the material actually turns black. And this is almost the color of of pure carbon. Seeing how radiation transforms simple ices into complex and colorful organic molecules should help interpret the close-up views of Pluto's surface that'll be sent back by New Horizons. Color translates to the duration of the exposure of these otherwise colorless ices over a year, 10,000 years, 10 million years. That may in turn tell us more about the nature of the exposure of Pluto's surface and even the age of Pluto's surface. Dale Cruikshank began observing Pluto back in 1976. Now, 39 years later, he's ready for its close-up. We can say that Pluto is chemically active, chemically dynamic. We don't know yet if it's geologically active and dynamic, but that's what New Horizons is going to tell us. We've been surprised in that way before, as we've passed other planetary bodies that we had thought were totally cold, dead, inert worlds, and find that there are geysers, there are ice flows, there are cracks, and all kinds of evidence for geological activity. I can still remember the first time I saw Pluto in a telescope, and it was just a little dot that you could barely see. It will be amazing that within a period of hours, it will be transformed from this tiny dot that I studied as an astronomer to this huge geologic world that will be able to see volcanoes and faults and ices and mountains and craters. I mean, it'll be truly an amazing experience to see it transformed. So from sophisticated lab experiments, from exploring other worlds, and from applying insights from terrestrial processes, what should we expect when we get to Pluto in July 2015? But the only thing that would surprise me would be if we turned out not to be surprised, but enjoying the scientific surprises to come means avoiding dangers on the last few million miles to Pluto. That's next. December 6, 2014. In Mission Control, Alice Bowman and her team wait to get confirmation that New Horizons has exited what's called hibernation. For 2/3 of its 3 billion-mile journey, most spacecraft systems have been turned off, saving wear and tear on the science instruments. New Horizons sends a simple signal once a week just to say, "I'm still A-OK." Alice's team has a unique way of showing spacecraft status. When New Horizons is hibernating, their bear mascot is safely asleep. When the spacecraft wakes up, they put on its party hat. If all goes well, this will be the 18th time spacecraft and bear have woken up. But December 2014 is different. VIPs from NASA are on hand. 2 film crews document the action as Alan explains the benefits of hibernation. It lowers our cost because we don't need to have people babysitting the spacecraft 24/7. Outside interest in New Horizons is building. If all goes well, New Horizons will stay awake, flying by Pluto in July 2015, and then returning data until October 2016. Copy that. Thank you, GNCs. Tonight, data trickles in, and Alice has to wait to be certain New Horizons is fully awake. We should be getting it momentarily. It should be any minute now. It's like watching paint dry. I figure if I stare at the screen hard enough, once I... And petrified just be men, here we go. Here we go. Hiam, PM, Mom on Pluto 1. We have a nominal wake-up of the New Horizons spacecraft on its way to Pluto. We're ready for him X-leg the dirty. Was awake. Our bear, he's gonna be here for a while. This is a watershed day. We have completed the cruise across 3 billion miles of space. The spacecraft is now awake, finally, after 9 years, and I'm glad to see hibernation behind us and active ops ahead here on to Pluto. But there are still hundreds of tasks to ensure a safe flyby in July 2015. January 27th, New Horizons has been sending back technical data, and all seems fine. But today is the first time Hal Weaver and Andy Chang will be seeing new science images. Well, I saw it pop up here. Now, let's try that again. Check. Chang is lead scientist for the LORRI camera. Lori is used for navigation to find the targets and to correct the trajectory so we get to the right place at the right time. Voltages, currents, temperatures all look normal. No error messages. This is it. Let's check out the very first images, and then Sharon, right there, Pete Pixel, it's 55. It's right, and okay. All right, so right there they are. Let's look at the whole. For project scientist Hal Weaver, even the jump in size from 1 to 2 pixels was significant. This is a real milestone in the New Horizons mission, the very first images of Pluto in the Pluto Encounter year. Hadn't turned Lori on, hadn't gotten any images since last summer, last July. But this is it. This is the start of it. There she blows. We really don't know what we're going to see. That's what this mission is all about. What is the surface of Pluto really like? How big is it one of the orbits really? So it's nothing but the delightful surprises coming for us. But some of the surprises may not be quite so welcome. As New Horizons gets still closer to the Pluto system, Lori will be able to identify small moons and possible rings that can't be seen from Earth. John Spencer is leading the UHAZ campaign. UHAZ stands for Unknown Hazards. We may find new moons or even rings around Pluto, and if we see anything like that, we're going to want to determine whether it poses a threat to the spacecraft, because if it does, if there's debris that we might run into that might damage or kill the spacecraft, then we want to evaluate that hazard and determine whether we should take any evasive action. To find out just how vulnerable New Horizons might be to even tiny dust particles, the mission sent samples of spacecraft components to the White Sands test range. Technicians at White Sands set up gun tests to assess how vulnerable New Horizons' outer covers and cables might be. We went to 2 facilities that could shoot things into parts of models of the spacecraft. While the results might look dangerous, the mission has options to take evasive action. One of the backup strategies we have we feel we need to give the spacecraft extra protection is that we orient it so that the high-gain antenna here, which is literally pretty bulletproof and can protect the spacecraft, is going to be facing forward in the ram direction. This is ram in the sense of battering ram. It's a direction in which stuff will be coming at us and ramming into the spacecraft. And if that is facing forward, then any dust particles that hit the spacecraft are most likely to hit that antenna where they won't cause us problems. And only a small part of the spacecraft around the edges is going to be exposed to those particles. That would protect the guts of the spacecraft, but limit the pointing of the cameras. The cameras are fixed to the spacecraft, so the spacecraft has to point in one direction. The cameras can only point in a limited range of directions. This limits the amount of times we can photograph the system as we go past it, because we can only photograph objects when they're just in the right angle that we can look at them while protecting the spacecraft with the main antenna. Another option is to take different trajectories through the Pluto system. That's called the Shabbat play. Shabbat is the best acronym in the space business. It stands for Safe Haven by Other Trajectory, and it is the word we use to represent our backup plans at Pluto. The second Shabbat takes us much closer to Pluto, into the region where abstract drag depletes orbits of any debris, which we think would be the safest Hail Mary pass that we could fly if we have to do something different than the nominal. We are coming into the Pluto system with the ability, if we learn something we don't expect, to be able to make a change and get the goods. But those decisions can only be made in the last month before closest approach, and there'll be limited time to evaluate the best options. So in February 2015, Spencer's UHAZ team, including ring specialist Mark Showalter and postdoc Simon Porter, are running through a readiness test. Now they're on the clock and being scored for whether they can work through the calculations fast enough to decide on a trajectory correction maneuver that might prevent loss of mission. And that makes this exercise more critical than any that have gone before. The difference between this and previous operational readiness tests is that this is where we have to demonstrate to the project to NASA that we can do this. But the only test that really matters comes on July 14th, 2015. That one day will pay off 26 years of dreams and 9 years in flight. For the science team, the Year of Pluto began with another meeting to review the latest data on the Pluto system and to hear updates on how the spacecraft was performing. Mission manager Glenn Fountain, who'd been with the project from its start, summarized remaining risks. Red boxes are possibilities that could kill the mission. But now, in 2015, there are more and more green boxes, risks that have been minimized. Something that we haven't thought of still might happen, but I'm confident that whatever happens, whatever fate throws at us, this team will be able to resolve it and we'll go on to get wonderful data when we get to Pluto. We have a fantastically talented team of people who have worked very hard, and we've tested the sequences inside and out. And while there are always unknown unknowns, I'm very confident and really looking forward to the curtain rising. Along with mind-bending technical details, there also was a sense of history in the making. To document the long years of effort to get this close to Pluto, the mission recreated a team photograph taken in 2004. As Glenn, Alan, and Alice had carefully planned back then, many of the scientists and engineers were still actively engaged in New Horizons and looking forward to July 2015. We have worked hard to get a coherent team because if you don't have a good team to operate the spacecraft, to do the planning, you will fail. And so we worked a plan early in the mission to have younger people with the right amount of experience to be on the mission. And it's just like watching your kids grow. It's like all of a sudden, where'd the time go? They are older, they're more mature, and they're now the very experienced veterans. But the hard work of mission planning was by no means over, even this close to Encounter Day. While exploring Pluto in 2015 is exciting in itself, New Horizons was recommended in part as a mission that might continue on farther out into the Kuiper Belt. That takes identifying potential targets now for a still more distant flyby, should NASA approve an extended mission. This challenging task was assigned to John Spencer, Mark Bowie, and a team of young postdocs. And like everything else about this mission, it wasn't easy. Bowie and John Spencer had been using Earth's largest telescopes in Hawaii and Chile, but even Earth's best couldn't crack this task. But the basic problem is the Earth's atmosphere is just a mess at these scales. There's a limit, and that's what we've been beating our heads against. Now, as time running out, we had to turn to Hubble. And so we sort of not so jokingly talk about Hubble to the rescue. Without Hubble, we would not have these objects. Mark and his young collaborators came up with innovative search techniques using custom software. What that does is makes the stars smear out and makes the Kuiper Belt objects hold still. It's been a lot of work, but to do something as exciting as this has been just so much fun. I've been playing through the data today because it's fresh data, and I just really, really wanted to know what the answer was. But we would have been in big trouble if we didn't find the KBO in time, so there was this pressure. But honestly, we had the best people in the world working on the problem, and we did it. And we just do the math, write the software, crunch the pixels, and then I create this graphic. And from that point on, it's what I call wetware. It's what you got in your head. In reality, KBOs are moving against the fixed stars. Mark came up with a way of making them more obvious by flipping that around and making the stars appear to move, and any KBOs stand still. Right in the middle, there's something that's just holding dead constant. And that's the Kuiper Belt object. You can't argue with that. It was a high-tech variant of the approach that had been instrumental in exploring the Pluto system right from the start. But at the core, it's a technique that hasn't really changed since Tombaugh's day. You have two pictures of the sky taken at different times, and you're looking for the stuff that moves. As soon as you see something real, There is absolutely no question about it. As soon as it flashes on the screen, in just a millisecond, there it is, it's real, and you know, I've found another Kuiper Belt object. But finding a KBO is only half the battle. Is it located where New Horizons can reach it with available fuel? Once you have the orbit, we know where the spacecraft is and where it's going to be, we can figure out how much fuel the spacecraft is going to need to use to get to these objects. With more Hubble time, New Horizons got a pleasant surprise. It looked like we might actually have to burn the engines to miss the object, which was pretty exciting concept. You know, it's a good thing we looked, because you would want to run into one of these things. These cold classicals, they're pretty much as they were 4.5 billion years ago. They're little fossils. That's incredible. We have no idea what they're going to look like. So with potential targets found at last, it was on the Pluto. I'm feeling pretty exhilarated at this point. You know, you're at the top of the roller coaster. You're about to go down that dizzying, thrilling ride into the system. Just seeing Pluto that getting bigger and bigger, it gives me goosebumps. Today, we're only a few months away from the encounter. We're less than an astronomical unit. The distance between the Earth and the Sun, that distance away from this fascinating object. It's the last major body in our solar system that we really need to visit to be putting the capstone on the initial reconnaissance of the solar system. It's heartwarming, and it feels like something that makes a career worthwhile. A spacecraft goes, New Horizons is a very small team, but still, we've been working on this for over a decade, and you add it all up, and it's about 2.5 million work hours to get ourselves to Pluto. We have waited first the 4 years that we could hardly think about because we were running so fast, and then it is, oh, we wait, and now we are ready to begin the encounter. We have had delayed gratification. The Year of Pluto is, simultaneously a beginning and an ending. It's an ending in that we are completing our objective. We're accomplishing the flyby of the Pluto system for the first time. But it's also the beginning of a whole new chapter for science, of really being able to explore these objects as the data comes down over a period of months. You know, in bringing in postdocs and the younger scientists too, some of them were in high school while we started this project. And now they have their PhDs and they are spectacular experts and very talented at what they do. I was in preschool when Alan first started talking about a Pluto mission, and finishing high school and starting college when it was built. And in grad school for the crews, having young people come into these programs, gaining the experience, they're going to be the next generation of explorers. We've never been to a KBO. We've never been anywhere close to a KBO. This is the most unexplored area of the entire solar system, which is another way of saying this is the most unknown area that we as humans can reach with spacecraft. We can't wait to get to Pluto and to July 14th and see what the surface looks like. We're ready to go, and it's showtime. We are capable of continuing an adventure that humanity began 100,000 years ago as our ancestors walked out of Africa. And we are continuing that exploration, and this country is in the forefront of doing that.